before I dive in, I just want to say I love this group, and so I wondered if we could give a big round of applause for Brian, John, and Dennis for putting it together, because they deserve it. The fact that you can get like a room filled with people for a talk on hypermedia with a guy like me presenting it just says what a good job these guys are doing with the group. So my name's Chris Marinos, for those of you that don't know me. Today I'm going to be talking to you guys about hypermedia APIs and I guess more broadly sort of REST in general. This talk, I think we're not going to talk a lot about JavaScript in terms of libraries or language features or other things about the JavaScript library itself. But chances are, if you're writing JavaScript, you're going to be interacting with a server in some way, shape, or form, whether you're writing it on the back end with Node or consuming it from the client side just in a browser. Web APIs are a pretty important topic for JavaScript developers. So hopefully, whether you're a front-end person, a back-end person, or a mix of the both, there'll be something in this talk for all of you. So we're going to start off with sort of a high-level overview of REST as a whole. Then I'm going to talk about the concept of hypermedia and how that fits in with REST and just what hypermedia actually is. Then we'll spend a little bit of time talking about affordances, which are sort of a key concept of hypermedia and the hypermedia formats that are available. And then finally, I'm going to give you guys a little bit of a demo to sort of tie that all together. So at any point in time, feel free to interrupt me and ask for questions. But if I say, like, let's talk about it offline or something else, don't be offended. It's just that I have a tendency to sort of ramble on a lot, so I want to make sure we get through all the content. As those of you who know me can attest, don't blame me, it's my ancestry, Greek and Italian. We talk with our hands and we ramble a lot, so that's just how it is. So let's dive in. The story of REST really begins with this guy. Does anybody know who this guy is? I mean, it's not like a great picture of it. It's just what I could find. Oh, somebody knows. All right, cool. Yeah, this guy this is Roy Fielding. He's the creator of REST. He coined the term and sort of defined all of the constraints in REST. And so basically, what he did was he put together a paper that I'm not even sure if he thought anybody was going to read, but it was his doctoral dissertation. And it outlines the principles and constraints of REST. And so he sort of went from on high and said, here are the constraints of REST, here's what it is, and here are the rules for defining it. And as you might be able to guess, with a set of rules or manifestos or things to follow, not everybody really agreed, and sort of some people had their own interpretations of what he laid out. And took some of the commandments to follow, the other ones maybe not so much. And so I think since then, Fielding, looking at some of his later work, he didn't really like that too much. And so he's taken a pretty strong stance about what REST is and what REST isn't. And like once you put something out there, it's sort of up to the public to determine what it is or isn't. But his voice should count for something, right? He's the guy that laid out what REST really is. And I think as we talk about hypermedia and all of the other constraints that Fielding originally intended for it, it makes a lot of sense in a way that just the way we throw the word REST around doesn't. So with that in mind, raise your hand if you've written or consumed a REST API. Okay, that's sort of what I thought. Everybody, right? And I bet that's 100% true. It's not a trick question. I mean, it's sort of a little bit of a trick question, obviously, but it's not really a trick question. I'm sure every one of you in this room has consumed a REST API or written a REST API in some way, shape, or form, but it might not be in the way that you think. And so at the end of the talk, we're going to come back to this question, and maybe you'll have a different mindset on it. Maybe you won't, but hopefully you will, if I do my job right. So I feel the same way. Like, oh, before, go back a year or so ago, even a few months before, and yeah, I'm like, oh yeah, I know REST. I've done it, and so then I stopped and I thought about it, and I thought to myself, what is REST? Like, if you had to define REST, if I just pulled one of you from the audience and said, here, you do the rest of the talk, you come up and you tell me what the definition of REST is. I thought I should be able to answer this, but it wasn't so easy. So like, if you had asked me a few months ago, I would have said something similar to this. REST APIs are where you like follow HTTP and stuff, right? And that's sort of where I feel like a lot of us are at with REST. Like, we know, like, okay, you should follow the HTTP verbs, and there's this like uniform interface thing, and it's statelessness, and there's all these other very loose abstract concepts that we associate with REST. But really what we're saying is we don't like XML, or we don't like WSDLs, or just let us write a stinking API and use JSON for it over HTTP. And so we're using the term REST to mean a lot of different things. And so I decided, like any self-respecting nerd, to just go and look up on Wikipedia what the definition was. And so this is what it said. Representational state transfer is a software architecture style consisting of guidelines and best practices for creating scalable REST web services. REST is a coordinated set of constraints applied to the design of computer components in a distributed hypermedia system that can lead to a more performant and maintainable architecture. So, like, no wonder that nobody can define REST, because this is the definition on Wikipedia. How are you supposed to understand this? But I do want to call out a few things about this mess of junk, right? First off, REST is a software architectural style. Well, that's weird, because that doesn't say anything about how you should write APIs. It doesn't say anything about HTTP. It's an architecture style? That's sort of odd. And this distributed hypermedia thing, I mean, what's that actually mean, right? And so the rest of it, I mean, there's some important stuff in there, I guess, but these are the ones that really stopped and made me think, like, maybe I'm missing something with what REST actually is. And so if I had to, as I researched it more and learned more about REST as a whole, I would boil it down like this. REST is the architectural style of the internet. And this architectural thing is pretty important, because I think when we think of, most people think of REST APIs, we think of, like I said, JSON over HTTP, following the REST verbs, structuring your URLs in a certain way. And we sort of think of things that we may associate with REST design, but REST is actually an architectural style. The way REST came about was Roy Fielding was involved in the sort of the early stages of building what we know as the internet today, the modern web. And if you read his thesis, he talks at length about the modern web. And it's kind of funny to think about it, because it's pretty old. I don't remember exactly when it was, 96 or something like that. But it's like a very different version of the web. But all of the fundamental constraints are similar to what we have today. And so really what Roy did was he was building the sort of the architecture and involved in the design decisions that created this massively successful system called the internet. And as he went about developing this, he basically started to form some architectural guidelines or principles, some constraints that he could build a mental model around, so that when he wanted to reason about new features for a library or a component that would go into, or a standard that would go into building the internet, he would have something to follow to see, did it fit? And so this was the topic of his doctoral dissertation. And it's a really interesting way to think about the internet, right? We think about the internet as like a place that you can go to, or something that lets you download your favorite book, or go and browse Amazon to go shopping. But what the web actually is at its core, and especially when Fielding put together his thesis, was that the web is a massively distributed, highly scalable, extremely decoupled, low latency system. And it's incredibly successful, right? We use the internet all the time. millions of people use it every day, and it stays up. It has its quirks here and there. Some sites can go down, but the whole internet doesn't crash. It's not like a thing that happens. We don't break the internet, and so basically this architectural style that Fielding sort of coined as REST is what makes that system possible. So if you want these traits in your APIs, being able to be massively distributed, massively consumed, have your APIs be highly scalable, very decoupled from one component to another, low latency. If these are desirable properties, then maybe we should look at what made the internet so successful, what made this REST architectural pattern come about. And so I'm not going to go into a ton of depth on these because we're talking mostly about hypermedia in this talk, but these are actually the constraints outlined in Fielding's thesis. So and a lot of these are covered by HTTP, but you'll notice that nowhere does it say anything about HTTP or JSON or a particular format like that. The REST constraints, client-server, so we're pretty familiar with that one. Statelessness, which is something that I think some people still struggle with in REST APIs. This is a pretty important one in terms of scalability and so on. The ability to have it cached, that's the cache constraint that he outlines. A uniform interface, which is something that we associate with, I think now with REST. We say, oh, it has to have a uniform interface. That means we have to follow HTTP. But there's more to this constraint. A layered system and code on demand, which is optional. We're not going to talk about it too much, but that's something I think in terms of future research or evolution of API development, that this may be an area for future add-on. But these are basically the things that Fielding identified as the core constraints that he's going to place on an architectural style called REST, and it helps him guide his decision-making in forming the standards that made the web so successful today. And so I think if you were to ask Fielding, he would say these are the things that allow the system to be successful. Not in a ton of detail. Basically, just that each component you can have a separate set of components from between client and server. So you can put a caching layer or a proxy layer, a load balancer in there, and each part of the system is sort of decoupled from one another. It's a fancy way of separation of concerns, basically. And so each of these constraints leads to benefits, and these benefits are what make the architecture of the web so successful. So the ability to reuse code across clients. So basically, by having client-server model and storing as much of the user interface, I don't mean UI in terms of how you lay out controls on a front end. I mean like the actual interface that a person uses to interact with the business logic on the server. By sharing that across many different clients, you have reuse. There's scalability and reliability in the statelessness. And this is something that I think a lot of people do struggle with REST, like I mentioned. Basically, if you have session state or cookie state, that really hurts your scalability and reliability as you start to branch out horizontally. It's not something we're going to talk about it a lot, but it's just something I wanted to call out. Caching, its performance, obviously. The uniform interface is something that's really key, and it doesn't get talked about much, but this is sort of where the hypermedia aspect comes into play. Basically, the uniform interface of the web, as we know it, is HTTP effectively. And so a lot of times when we talk about REST, we're talking about REST as it applies to the web or web APIs, and thus as it applies to HTTP. Layered system, visibility of the interactions between components, and basically your separation of concerns, simplicity of developing each component. And then code on demand adds further extensibility that you can sort of generically apply to clients. But these things are effectively what make REST successful for the internet, and we can apply these same concepts to our individual web APIs when we build them in JSON or with any framework, any server-side and client-side components. We can take these same core constraints, and we can get the same benefits. So notice in this, I guess first, does anybody have any questions before I go on? Because we're going to wrap up on REST as a whole pretty soon. So it's like the high level of it. Jay?
Authorization and authentication, form of state.
Fielding would say you send it with each request, right? So you use your authorization headers to pass, you don't keep cookies or state or anything on the client. You can keep state on the client. You can keep the credentials stored somewhere, but you send it with each request. So that the benefit is that if you're going to scale out your system server side, you can have many different, basically all the information needed to process any request is contained in that request for the server. So you can scale out horizontally server side and meet demands, or for caching, things like that too. So that's what he would say, and that's what a RESTful style would entail if you're going to follow his definition of REST, which you're free to do whatever you want, but that's sort of not following the rules, right? It's sort of something. He would say, stop calling it REST then, just make up your own pattern. But yeah, so that answered the question? Yeah. So it's just a different way of thinking about REST than I think a lot of us think about it, when thinking in terms of architecture. So again, none of those constraints mention anything about HTTP. The closest you can come to it is the uniform interface requirement. And basically, as it applies to the web, we use HTTP, but these same architectural principles can be applied to any system. You could use any different transfer protocol. Yeah.
Did he write anything about discovery in his overall architecture?
Discovery of?
The API.
Not explicitly, but that's one of the key things that we're going to be talking about in terms of hypermedia. So I'm going to touch on that a lot later on. But yeah, that's a really good question. So he doesn't talk about HTTP a lot, but what Fielding does talk about a lot is, in terms of what REST is designed, is this idea of hypermedia. So if you read the thesis, he says that this whole system, all of these constraints, are built on the idea that you're going to be building a distributed hypermedia system. And that's something that I know I sure as heck didn't think about when I considered REST APIs even 6 months ago. I just thought JSON, 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 JSON. Maybe XML or something else if you wanted to specify that content type. But it was all about those things and not really much about hypermedia. So if you're going to listen to what Fielding says, or I guess listening to what I'm saying right now, you need to understand that hypermedia is a constraint for REST, but HTTP, not so much. And if you don't believe me, Roy Fielding puts it pretty clearly in this quote. If the engine of application state, and hence the API, is not being driven by hypertext, then it cannot be RESTful and cannot be a REST API, period. So he's pretty staunch on this point. Yeah?
Is there a formal definition of hypertext?
There probably is, but I'm not going to go into that level of nerdiness for this talk. I'm going to go more applied with the hypertext for this talk. And we're going to see some examples of hypermedia and hypertext and things like that. But I'm not going to. I actually almost had a slide doing that. I'm like, there's no way people are going to listen to another definition as I go through the talk. We actually have to get to some applied stuff. So there probably is somewhere, and he actually has a blog post where he breaks it down that you can find somewhere. I think if you look up the REST APIs must be hypertext driven, you'll see, I think he links to it and says, somebody's like, what is hypertext? And then he links to it, and so you can find it there. Okay, so I'm going to pause here, and we did our REST overview, and now we're going to dive into hypermedia. Before I do that, any questions? Yeah. Maybe. I'm not sure. Like, I think so. I don't know exactly what you're getting at with that, but probably you'll see more about what I mean by driven when we start showing examples of it. But yeah, the client should be able to consume hypermedia is effectively what he's saying with that. Hypertext, hypermedia, I'm going to use them interchangeably. That's something I'm not going to be a stickler about. So I guess you can skewer me on that one if you want. Yeah?
Is JSON considered hypertext?
No, I'm going to cover that very shortly.
And why not?
Well, I'll cover that too, buddy.
Now you said RESTful is not just an HTTP, but I'm assuming most people here have only seen it in an HTTP environment. Are there other environments that you might see it as commonly used?
Not as commonly used. It's a way of describing the architecture that made the web successful and led to the standards that went into HTTP and other things like that. Practically speaking, most of the time when we're talking about REST and hypermedia, we're talking about over HTTP. And I think I don't know if that was in my presenter notes at some point on this slide or like another slide, but I was going to make it pretty clear that no, we're talking about, for this, the purpose of this talk, we're just talking about HTTP. Okay. So this leads us, the idea of hypertext as the engine of application state. This is a stupid acronym, HATEOS. It just doesn't, who puts hate in something they're going to try to market? It's just not, I don't know why you did that, but it's not something that I really like to have. So that's why we rebrand, or not me, the REST API community sort of rebranded this as Hypermedia APIs, because this is just a horrible idea. But this is what Fielding says is, you got to have hypertext as the engine of application state. And this is actually mentioned in the thesis, or in the dissertation, but very briefly. And he actually says, we're going to talk about it in the next section, and then he doesn't talk about it in the next section. Dude, come on, give me some material for this talk. Anyway, so what is hypermedia, Jay? Let's get more concrete with it. So I like to explain it like this, basically. This is called the Richardson maturity model. It's put together by a guy named Leonard Richardson. And it basically, if Roy Fielding has a black and white view of what is REST and what's RESTful, this is the shades of gray. And so Richardson says there's levels to being RESTful. And I think Fielding would say if you're not here or above, you're not RESTful. But here it's I think it's nice to illustrate the evolution of how I think about REST APIs and that sort of design. So I'm going to go through briefly at each level, and I sort of apologize in advance if any of these examples have the wrong domain in it. I switched domains an hour before the talk from a medical model where at the client where I'm working to a more generic consumer model. So this is level 0, plain old XML. This is SOAP, basically. It's using HTTP as a transfer mechanism for data, but it's not really following HTTP at all. So it's not using the uniform interface of HTTP really at all. It's basically you post to a root URL, and if you're in XML, you might have a SOAP request, and it'll look like this. And you'll say, I want to get a customer, and here's my customer ID. And I apologize if you guys can't see it in the back. That's the downside of slides. I can't move it up as easily. But basically, you'll send a request, and you'll send it over this my service, this one endpoint. You'll use a post or something to send it. And you can do the same thing if you were just using regular old JSON. You're going to say, I want to get customer, and here's the customer ID, and I'm going to post that my service. And so we're not following HTTP at all. We don't have any. Our whole API is one HTTP endpoint, basically, and everything's funneling through there. It's not to say that there's necessarily anything wrong with this style. It's not an attack on SOAP. It's just saying that this is further away from. If you're using HTTP as your uniform interface, this is the furthest away from being RESTful in that model, according to Richardson. So level 1 introduces the concept of resources, and this is where we start to get into, I think, more familiar territory for a lot of people when they think about REST APIs now. We'll have a customer resource, and you post to the customer, and maybe you still have some screwy logic here, like we're going to have a get. And so everything's going over posts. We're not following the HTTP verbs. We're not really treating the whole spec with a lot of respect, but we're we're starting to get there. And so we're going over HTTP, and we're saying get customer, and here's a customer ID. But we also have this organization resource. So now we've broken our resources out a little bit, in terms of our URLs, but we're still kind of playing fast and loose with the verbs. Our post, our get, we're mixing those things up. We're not following all of the HTTP verbs. We're not using puts, deletes. We're ignoring cache headers, things like that, all that other stuff. And so level 2 introduces this concept of verbs. And so this is probably where I think, at least I'm going to speak on for me, if I would have gone back a few months ago, this is what I would think of as REST, right? I'm like, oh yeah, I got it. I'm going to do a get to organizations and a post or a put. I didn't put on here, but I'm going to get an organization, and it's going to have this ID with this name, and it's going to come back, and then I can post to the organizations collection to create a new one, and I'm going to say it's going to have an ID of 999 and a new title, and then I can get from that same resource. And so there's other things on here, other verbs that you could follow, but this is basically following HTTP pretty. This is the level at which you're starting to really follow HTTP. You're honoring your caching. You're going through on your verbs. You're following the uniform interface. And so what Richardson would say is that, yeah.
What's the difference between the first get and the third get?
This is just to illustrate that. So if it's a poor way of illustrating. This is the first get to an organization, and this is the sort of the organization's resource. This could contain many organizations. Like, this is just one. Maybe it has organization ID of 1235 or something like that. And so there could be many more of them. And this is getting an individual resource. Sorry, I don't know what happened there. Lost connection here. Uh-oh, I just got a spinny beach ball. Okay, hang on. I think we're back.
So basically, if you ran the first one again, you would get those 2, 1, 2, 3, 4, and 9.
Yeah. So we were here. Basically, this is just getting an individual item or individual organization. This is getting all of the organizations. The point is that we're just sort of following the HTTP. Whatever your URL structure is, a get retrieves that resource. A put creates or updates that resource. And a post, you can either use overloaded post to do anything or append to a resource if you're following HTTP. So I wouldn't get too hung up on the actual meat and potatoes of each of these endpoints. These are just high-level demo endpoints to say, if you were creating an organization, appending to the end of the organization's resource with this request body, and you did a get to that URL, it would return the same resource. Does that sort of make sense? Okay. Again, these are just meant to be like real high-level illustrative concept slides. Okay, so we're getting to level 3 of the Richardson maturity model, and this is where we start to introduce hypermedia. And effectively, what it's saying, I'm using HTML as a hypermedia format for this one, so it should be pretty, you guys are JavaScript developers, you should be able to follow this one. So we're saying if we do a get on the organizations page, or organizations resource, we're going to return this content. This is what's going to come back, and it's going to have a descriptor on here, or we're going to get to this affordance word, but it's saying if you post to that URL, the organization's URL, using this input, so filling in the blank for organizational name, and you hit that submit button, then you're going to issue sort of a state transformation. The server is telling the client what it has to do in order to create a new organization on the server. And so the client is pushing down the state of the resource and all the resources, as well as an affordance to go to the next resource, a state transformation. So it's describing how you navigate the API effectively. So it's saying if you post to organizations, you can send me this data, and if you hit the submit, then then you're posting here. It's not doing the semantic information of what that actually means. So we make a little bit of a distinction between what's called the protocol state, which describes the way in which you can interact with a server, and the application state, which is what that actually means to a human being. And REST just solves the protocol state issues. It doesn't handle the application state. Yeah? In this example URL, I'll go into more of a demo of how you can do some of that like you could actually see what it might look like in a different context that we can play around with. But this resource definition might contain, so at organizations, you might have below it a list of all the individual organizations, as well as a form to create a new organization. So this is an abbreviated request just to illustrate that point of the server dictating state. The idea is basically, it's similar to like if you went to google.com, for example, and when you go to google.com, you get the basically the root page, and it has an input box with a submit button. And it says if you press this button, fill in this input box, you should issue a request to this new URL. And when you get the response back from that, it's going to have basically a list of all of the places you can go, the results of the query, and links, affordances to go to the next website. And you might have affordances like on the bottom too, a previous and next button to go through all of the different pages for that search result. I think it'll make a little bit more sense when I actually dive into a hypermedia format, which is what's coming right next. I'm going to change networks to see if that helps. I'm on the guest network now. Let's see if I can. And we are back again. Okay. So again, the key thing, and it'll become more clear, I think, as we look at more examples of hypermedia formats, is that we are basically the server is describing the state transformations as well as the resource state itself, and that's all coming down from the server. So now let's talk a little bit about affordances. Fielding's idea is that you should be able to enter an API with no prior knowledge beyond the initial URL. Leonard Richardson and Mike Amundsen call this the Billboard URL. So if you were to put this URL on a billboard and you said, go to google.com, a client should be able to consume google.com with just an understanding of the basic media types. In the case of your web browser, that's HTML. The web browser understands HTML, and it understands how HTML can describe how to move throughout the system. And so with just that understanding, it can use the entirety of your API. It doesn't mean that the consumer necessarily understands the application value of manipulating those resources, so it's not going to solve the problem of what happens when you click that search button, but the client knows enough to tell the user, hey, you can click a search button. And so I like to think about it like a text adventure game. Have you guys, I mean, this is sort of a silly question. Raise your hand if you ever played a text adventure game. Okay, yeah, you gotta know your audience, right? And so if you think of a text adventure game as sort of like this state machine, it's really what it is, right? You're in front of a house, you can go east, west, north, south. You can open a mailbox, and these are all state transformations. And so if you think about this sort of like the model for the web, it's not that much of a mismatch, right? The web's a massively more distributed version of this, but effectively, it's all state machines and transforms. And so I don't know if you've playing these games, if you ever ran into the frustration where you're like, okay, I want to open the mailbox. And they're like, oh, no, we can't open the mailbox. And you have to find the right word that it wants in order to describe how to interact with it. Well, that's sort of what I think of as like current REST, right? You have to figure out where the resources live on the server and what actions they're going to take. So like maybe you can post to this one, or maybe you can't, or maybe it's your URL structure is customers/1/purchases or something like that. You don't know as a client. You just don't know. You have to guess and figure it out, and you got to type different things. And so what Hypermedia is really doing is allowing the server. It's basically when you could type that little question mark and see, you can go east, west, and south from this state. And then you move to another one. You can move north and south from here. And then it says you can open the mailbox, you can close the mailbox. You don't have to guess. And while it might not be as fun for a game like this, it's really a lot easier to solve the game if you know all the different things that you can, the possible inputs that the system takes. It's much, much easier. And so that's what I mean when we talk about affordances. An affordance in a text adventure game would be something like you can open the mailbox, or you can go north, or you can go south. And so imagine the difference between playing that game without knowing anything about it, about the possible state transformations, and just having this little documentation about what you sort of maybe could guess at doing, versus having a very finite descriptive list of what the server or what the state machine will accept. And that's where Hypermedia comes in, is bridging that gap. It doesn't tell you what's going to happen if you open the mailbox, right? That's up to you to figure out. But it is telling you that you can open a mailbox or close it. And so this leads to this idea that when we talk about Hypermedia, we start to shift the way we think about building our APIs. Instead of focusing, and I see this a lot on like the mailing lists, people spend a lot of time thinking about how should I structure my URLs? Should this resource be nested in this one? Or how does my URL structure need to work? And I think we spend a lot of time doing that because we're trying to find a way to be more descriptive to our potential consumers, our clients. We think that's the way to do it. But the thing is that like clients don't really care about what your URL structure is, right? They care because that might be the only mechanism they have for interacting with your URL, with your API. But what a client really cares about is the state transformations. What can I do with your API? And so when you start building Hypermedia APIs, you start to focus on state transitions over just the basic URL structure. The URL structure is just a secondary thing. It's an artifact of building your API over HTTP. But in general, you're focused much more on describing to a generic client how to communicate with your API. And if you do this, it leads to a lot of cool benefits. It's a lot easier to discover your API, and I'm going to show some examples of what that looks like in practice in the demo. But it's a lot easier to discover and sort of self-document your API, because you have to do that for the client anyway. You get benefits of reusing the state transition logic. And what I mean by that is, I don't know if you guys have been in a situation where you had to work on an Android app, an iPhone app, and a web app, right? A traditional browser-based app. And so what ends up happening is you have to code in all of your clients knowledge about the server and what exists on the server. So you have to code the URLs for products or customers or shipments or things like that. And you code that into your client because the client has to know something about where the server stores that information. But if the server is pushing down everything it's capable of to the client, you don't have to store that information anymore. All you need to store is the root URL, the Billboard URL, and the knowledge of how to manipulate those resources. So you code the stuff that you care about, the application state. And that makes it easier to develop your clients because you don't have to find a place to hard code that information. You don't have to fill in URL templates and stuff like that. You have a generic client capable of interacting with a generic Hypermedia format that allows you to access the whole breadth of the API. Now you need to make sure that as a server developer, if you're on client side, you need to go beat your server developers to make sure that they're designing an API that's consumable for you. But assuming you're both agreeing on Hypermedia, it makes it a lot easier. And then it also gives more flexibility for servers to evolve. A server can choose to change where URL lives And as long as it doesn't change the rel, and I'll show you, I'm not going to show an example of it actually changing, but I'll show you like a rel versus an href, and if they don't change the rel, then the client keeps on acting like it always was, and they're free to change the URL structure as they want, as long as they're not breaking the application level contract, the semantics of how a client could interact with it. So again, when we talk about hypermedia, we talk about hypermedia formats. And so notice that doesn't mean JSON or XML. You can bolt some of this functionality on top of JSON or XML, but by default, JSON and XML don't have any of these affordances. So they don't have any way to describe state transitions. You can sort of put that in there, but there's no semantic meaning to it if you put it in JSON or XML. JSON doesn't have the concept of a link built in, for example. So these are just a few examples: XML, HTML, XHTML, collection plus JSON, which is what we're going to talk about in this talk, Siren, Hail, JSON LD. These are hypermedia formats. You can go and look at them. They're well documented. And basically what they do is they communicate how they have these built-in things that I refer to as affordances. They give ways to describe how you can move through the system, how your north, south, east, west, where your mailbox lives, things like that. These hypermedia formats allow you to describe that and include that descriptive information in the response right alongside your data. And so I mentioned collection JSON. It's the one I'm most familiar with, and it's the one that I think maps easiest to our current way of thinking about REST. I think we have a very CRUD way of thinking about REST currently, and a very collection-focused way of looking at it. I think that's in large part due to sort of Ruby on Rails and the adoption of other frameworks and how they sort of defined REST for us. So I think collection plus JSON maps nicely to it. So I'm going to break down the affordances that collection plus JSON offers to everybody. Or I'm going to break those down, and then I'm going to go give a demo using collection plus JSON so you can see what a hypermedia API might look like in the real world. Before I do that, does anybody have any questions? Okay. So this is collection plus JSON at a high level. Collection plus JSON, the document enforces, the hypermedia format enforces some constraints about your response. It basically says that all of your responses have to be in the form of a collection. And the JSON part means it's in JSON, right? So all the responses are going to be in JSON, but there's additional semantics bolted on top of JSON. So at a high level, this is what a document would look like. There's a version specifier, and this is the version, not of the API, but of collection plus JSON, the format. There's an href, which corresponds to the URL of the current resource you're getting. There's links, items, queries, and a template. And items is the key one. That is your collection. So we'll break down each part of it and what the affordances provided by each section in collection plus JSON do. But this is the high level. So imagine if you have a set of customers or organizations like we talked about before. You have these high level this high level concept of a set of customers or a set of organizations, and that would go in your items. And then each item can be represented as a collection of one. Each customer could be a collection of one. Yeah.
I'm not sure whether I'm asking a good question, but how do you know that links, items, queries, and templates can be obtained from the API you're pointing to?
So basically there'd be a content negotiation step where the server would say, I'm serving you a document that is collection plus JSON, and the collection plus JSON spec specifies which of these things must occur in the response, which of them are optional, and how to handle sort of a little bit of semantic meaning about how a generic client should interact with these sorts of things. So basically there is meaning associated with each one of these fields in the response, and that's what constitutes the affordance. So it's a contract, a formal specification of collection plus JSON.
How does one get that specification?
It's on the collection plus JSON RFC. Just go to Google, type in collection plus JSON, and then Mike Amundsen, who's the creator of the format, has it specified in a formal RFC so that anybody can implement a generic client in collection plus JSON. So there are clients in JavaScript, in Python, Ruby, C#, lots of languages that can consume a generic collection plus JSON hypermedia document and provide the ability to navigate through this and consume those affordances. Yeah.
So items is an array.
Yes.
Contain objects. Does each object have collection, version, blah, blah, blah?
No, and I'm going to show you exactly what it looks like. I'm going to break these down so you'll see each section. I just wanted to give the high level of the whole response of what a generic collection plus JSON would look like. So here's what links would be. So links at a resource level is just saying here's another place you can go in the system. So when you enter, so a lot of the APIs that I've written so far have at the high level they have like base level resources. So I have organizations and customers here. So I'm saying you can go to this URL and find out about organizations or find out about customers. And it's just linking to, at the resource level, other things that may be associated with this resource. So if you're standing in front of the mailbox, this is the link that might say you can go east or you can go west to go learn more about my API. And this is what the actual item response looks like. This should help answer your question. Each item is not going to have the full collection plus JSON response. It's just going to have an href to get that individual item. So this is to get the representation of the first organization, and you would have organization 1, organization 2, organization 3 repeated throughout here. And within that organization, you have the data element, which this corresponds to the fields on that organization. So this is saying this is the organization ID, and its value is my org, or that's the value for that name. And then each item in the returned array can have a link associated with it, or a link array associated with it. So this is saying organizations can have customers associated with it. There's a sort of like a one-to-many mapping, and this is how I'm modeling it in collection plus JSON, saying, okay, you can go to this URL and find this customer, and we could maybe repeat this. And this whole items array, and you'll see an example of where I have a bunch of them, but the idea is that this up here can be repeated. So you can have another item below with another href, data associated with it, and links associated with it. Lots of questions, good. I saw your hand up first.
Yeah, earlier you mentioned that if you have an API that works like this, you don't have to hard code URLs of the client-side apps that you're working on. I was wondering what the appropriate way of actually getting the URLs would be, because it looks like you could, when you boot up, walk through the entire API at runtime and just like save everything. That seems kind of inefficient.
So basically, yeah, it depends on your API design, right? So a lot of this is just up to the server and the client to figure out as it evolves over time. So if you might, let's say you're writing an API for Facebook or something like that. When you load up, the client, the Facebook client, could go make a few requests, fetch the posts resource, and then at runtime, go ahead and grab the list of all of the posts and load that up and render it real time. Now you might say, okay, well, hang on, how often is it really going to change that post is going to move to a different URL or something like that? That's a pretty fixed resource in my collection. So you might set a cache header on that and say, clients, you can cache this for 48 hours or something like that. And as a server developer, what you would do is you'd say, okay, if I'm ever going to change where posts live, if I ever want to not change that hard-coded URL, I'll first issue a redirect. And so I'll gracefully degrade if anybody hits the old URL. Then I'm going to change maybe first you change the root level resource, and then so the next time somebody gets the cache, they can go to the new one. Then maybe you give it a redirect, and then deprecate the API, and then remove the API. So it can evolve over time. Does that help answer the question? Okay, cool. Yes?
Okay, so how would you know which one's the post, which one's the get? Should that also be?
That's something that's defined with collection plus JSON. It assumes that you're using HTTP, and so it follows HTTP semantics for this format. So if you do a get to that resource, it's going to be an HTTP get. If you do a put to it, it's going to be it's going to have those semantics. So the protocol, the Hypermedia format doesn't specify, if you do a get post or anything else. So you'd have to do like an options query to figure out what each resource could support. But you'll see a little bit below where it gives you more information. You have the ability to give more information about doing puts and posts and how to construct your responses or your requests to the server for that. I'll show you that in a little bit. But it doesn't hard code any information about specifically for each resource what the semantics of a put or post would do. You just have to follow HTTP on that one. There's another format called Uber that the same guy that wrote this has that is sort of protocol lists, and that might get into more of the semantics of documenting what each resource is capable of doing. Does that answer the question? Okay.
Each ref value, in your example, you're basically getting the same physical server. Can I, in this same structure, the second each ref go to a different server?
Yes, and I'm going to show an example of that in my demo. Okay. So we have a couple more affordances to go over, and then it's almost demo time. So just facing yourself. It's not a super long demo. Don't worry about it. So this is a queries affordance, and this sort of is the Google example I talked about before. It's saying if you want to do a search on this collection, here are the different types of queries that you can perform. So it's saying, okay, if you go to this URL, this search URL, and you can basically give it a query parameter with a last name, so you can, question mark last name, and you can set a value in there. And so that value is sort of like a placeholder. So you could, if you wanted to, you could put in like Bob or something like that for the first name. That's basically what it's doing. Is it's saying here is a template for you to construct a query, and if you use this query, if you create a request to this URL, you'll be able to do a query against the customer's resource. It doesn't necessarily tell you what the query is going to do, right? So you might, this last name, this is obvious to a human that this is a last name search based on the URL documentation and sort of the rel here. Like you can figure out what it's going to do, but if you had a more complicated search example than this, it's not going to help you with that. But it's just telling you, hey, here's a mailbox. You can open or close it, is effectively what this affordance is doing. So it's just saying you can construct queries to this URL, and the server's going to respond with something. And generally, based on how the server would implement a generic collection plus JSON response, you know that it's probably going to be limiting the result set of the query. But it could do anything. And the last but not least is templates. So this is if you want to construct a new resource on the collection, you can give it basically this is telling you how to construct a new resource. So if this is a customer resource, you can give it a first name and last name. This is sort of like an HTML form, right? You can, it's saying, okay, to any client, here's a prompt. Give it the first name and last name. And if you submit this, the server will accept these fields. So it's documenting all of the different state transformations that you can have for this resource. How to create a new one with a template. How to query against all of them with a query. How to go to another part of the system with a link. How to access an individual resource with the rel on the resource in the items array. And so all of these things are just, it's not a revolutionary new idea that's getting applied to REST API. This is an evolutionary step. So you start with your JSON, and now the server's sort of telling you, hey, here's the data that's going to get returned, and here are the other things that you can do. So I'm about to jump into the demo now. Before I do that, questions?
Yeah, is all this data, are we assuming that all this data is being sent to the client every request?
Yes, the rough structure of the document is going to send with every request. It doesn't mean that, so getting into like, I'm assuming you're asking with performance in mind, latency in mind, there is going to be some overhead in having a big request with all this stuff coming in every time. But if that's a concern, there's nothing to say that you would have to send like a queries back for every single data element in it. You can control, at the resource, I guess like at the collection level for a resource, you can send queries and that and other information, but you don't have to send it for every little item lookup. So you can play with this as a server developer. The idea is that you're just communicating to a generic client what you're capable of doing, but you could also link them to like let's say you were doing like an overnight batch processing or something like that. You could link them to a CSV file. Just like HTML, you can link to an image. And an image isn't really a hypermedia format, but you can link to other ideas. And collection plus JSON, I didn't specify it, but it does have the concept of linking to images or things like that. So you don't have to have your entire API surface area be collection plus JSON or any particular hypermedia format. You can mix and match. So you can say, this is going to go to a bulk CSV load. And as a generic client, you're not going to navigate from that CSV file to something else, but you can navigate the API to get to that CSV bulk import. So you have some flexibility to solve performance problems. It's not like you're locked into, you must do it this way for every single request. Does that make sense? Okay. Any other questions before I do a quick demo? Sweet. Oh. Okay. So that's not showing on the screen. That's in Rome, Pont Sant'Angelo in Rome. You like my picture, huh? Okay. So can you guys read that in the back? Is that visible, or do you want me to try to blow it up a little more? Let's do one or two more. Thumbs up in the back if you can read. All right, awesome. We're rocking and rolling now. Okay, so this is Postman. It's awesome that you guys are familiar with it. So I'm going to create a request to, this is just running on my local host, this service on port 8000. Take note of the port because it's going to play a part in the demo later, like I was mentioning, to REST API. So this is one service, and this service is going to deal with organization, or basically customers and transactions. Imagine we're going to have a customer's service and a shipping service. And customers, basically this service that we're looking at is the customer's one. It's going to deal with customers and transactions. And we're going to have another service that deals with shipping info, routes and destinations. So this is the collection plus JSON document at a high level. This is what it looks like in practice. So this is my Billboard URL, localhost 8000. I'm going to put on the billboard and say you should go there. And you go to localhost 8000 on my machine, and you come back with this response. It's saying, hey, we have customers and we have transactions. You can feel free to look at either of them. And so we could customize this with links to any part of the system. But just for this demo, I'm going to choose that we'll start off with customers. So a generic client consuming this would say, okay, well, I want to investigate this customer's thing. So I'm going to take the rel, and I'm going to follow the URL that's associated with that. So I'm going to go to customers. And now I have a set of customers that's returned. So you'll see here that the href corresponds to this resource, and the items array is now properly filled out. So this is the first customer, Tom. And as I scroll down here, you can see Tom, Dick, Sally, Jane, Mary, Bill, Fred. These are all different different customers in my system. So this is the body of the response. And each one has a link that says, if you want to interact with any of the customers, here's where you go to interact with that customer resource. So the spec is pretty loose here about what you return at the collection level and what you return at the item level. In this case, it's demoware, right? So I only have a name. But if I wanted to be, if I didn't want to return the whole body of it, let's say I have a very complicated object, I can just return part of it and then say you have to go to the individual collection, the individual item level to see more. And also down here, I have links. Now this is the link at the collection level. We're going to talk about the links at the item level in a second. But at the collection level here, for those of you in the back that can't see it, it says next. And the rel is corresponding to page 2. This is the URL. I wish I could put this up higher, but it'll come up in the address bar when I hit enter here. This is, well, for my particular demo, this customer has 3 transactions. This customer has 1 transaction. This customer has 1 transaction. Apparently, some of them have the same transaction. Maybe not the great demo, but whatever. So you'll, it's at the bottom. It's because I was like, oh, I'm not creating 10 transactions to map with 10 customers. I'm just going to fill in. I wanted 15 of them, so I just entered names real quickly. But I mean, that's part of any document, right? Some of them might have links, some of them might not, and that's part of the idea of that Helios word, hypertext as the or hypermedia as the engine of application state. These resources don't have transactions, so I'm not going to put them in there because it's not a valid state transition or a valid request for the client to make. So I'm glad you brought that up, actually. That's another point that I should have touched on, is that if it's not valid, if the client can't go there, the server's not going to tell the client that they can go there. It has to be a valid URL. Now, it doesn't, the URLs could break or something like that over time. You can return response codes, error response codes, redirects, things like that by following HTTP. But the idea is that the server is modeling what it knows about its current state of the world. Does that make sense? And that's one of the really cool things about this hypertext, hypermedia as engine of application state.
A simple question, I hope. Are other hypermedia specifications similar? Have the similar?
Yeah, and that's another thing I should have made more clear, is that other different hypermedia formats have different affordances, but most of them have the concept of links. Some of them have the concept of resources and queries, and some of them support posts. Some of them support other interactions with puts and posts within the descriptive affordances that each hypermedia format applies. I didn't want this to be like a really super boring. I mean, it was already boring enough going through collection plus JSON. I didn't want to go through another hypermedia format and say this is the. But there's, if you go to, I'm going to show you a book at the end that talks about all of them in a lot of detail and sort of the trade-offs of them and what each one supports. But you can think of a lot of them as sort of a subset of HTML in terms of the types of things you might expect to see, embedded images or links or forms, things like that. It's sort of what you might see in HTML. And because HTML is like the OG hypermedia format,
How would errors appear at this level? In other words, I'm assuming that for sure you have to have a name. And occasionally you might have a transaction. What if you just get a transaction and do the hit? How will it show up at this level that you have an issue?
if there was an error, so that's one thing I forgot to, or I don't know if I forgot or ignored about the whole thing, was that there actually is in the collection JSON spec a errors response. So I might actually be able to trigger one for you. I'm not 100% sure. This is really going off the beaten path, but I might be able to show you an error response. We can play with it and see. It's my own custom little. Yeah, we'll play around with it real quick. So I'm going to follow this next link down here, And so this is basically, if you're thinking about this in terms of the Google model, this would be going to next, clicking the next button in your browser, but this is within collection plus JSON. So I followed the rel to next, and this is pointing me to this URL, page equals 2. So this is how you'd handle pagination in a hypermedia format. Now I'm getting a brand new set of customers, and at the bottom here I have a link to go back to my previous set of paginated results. So this is effectively saying I got, you can go to page 2 or page 1, and since there is no page 3, I'm not going to link to it because it's not valid. Just like on page 1, I only linked to the next link. I didn't try to go to page 0 or -1 or however you want to index it. So this is one state transformation through the system. Now, I don't know what's going to happen if I go to page 3, but let's see. Hey, all right, demo-ware works. Error, message not found. So the error message is saying page 3 wasn't found. It's a very generic error here, but that's about what you could display this back to a user just saying, we couldn't find this page. And it does return, if it's not clear, 404 not found. So
That's on a page. I was more concerned about an item. I'm glad to have that at this level.
yeah, I guess if at the item level, if it didn't exist, it would probably give you something similar. It would give you whatever. Yeah, I mean, it depends on the type of error, right? So, and how robust you code your server. So you can be descriptive about it, or not. You can return different error codes here. This is just my generic error code. I thought you were going to be impressed that I got an error code. Come on, man. Why you gotta be that way? Okay, so let's go back here to the first page that we were on. And now I want to look up a transaction. So I'm going to follow, actually first, just for kicks, let's go to the first customer. We can dig down into that just to show you what that might look like. You see now we have a lot less of the junk in this response. We just have the first customer, Tom, and here's the transactions that Tom has. We don't have links to other things because they're not really relevant for a customer. The only links that we have are the ones that apply to this individual object. So what I mean by links is the links down here at the bottom. Like this resource, it's at the high level, it doesn't have links associated with it. The links apply to the individual item. And since it's a single item response, this would be, we could start to issue puts against this and have it update the transactions. This is a read-only API. I don't have the writing capabilities put in here, but that's how you could update one. So I want to go in and look at a transaction. This is another part of what I'm considering to be the customer's model or the customer's service. So we're still on port 8000 here. I'm going to go and get the first transaction. And so you see now we have another resource that comes back, and it's an individual resource, transaction 1. It has a confirmation number, TK421, and a link to the route. So if this was a transaction, this would be saying we're going out to our other service, whether it's UPS or some internal shipping provider, that's some shipping service that has more information and is responsible for the idea of shipping information itself. And so this is on localhost 9000. So it's a separate service with a completely separate, it could be written in anything else. It just happens that these two are written in Python, but one could be in Node, one could be in Python, one could be in C#, one could be on, the other side of the world running with a different organization. Just like Google.com doesn't have all of their stuff hosted on their same domain, it's linking to other parts of the web. And so this is just saying, here's a link to this routes service, and this is going to contain more information about the route for this transaction. So if I click this bad boy, it's going to go to 9000, routes 4. Yes. Okay, so now we've gone to another service, and this is the individual route for that customer, that transaction, and then this route just has destinations associated with it. So I just said a route has several different destinations, and we can dive into each one just the same way. So that's sort of the high level of what a working part of this would look like. I didn't show queries, I didn't show templates, but this is just like the meat and potatoes of how you can navigate through a system by doing the state transformations and consuming a Hypermedia API. Questions? Yeah, I saw your hand first, so. For this API, the way I've designed it right now for the demo, yes. But remember what I talked about before. You could cache at any level of it. So if you're hitting, if the server sends back a cache header, you can say, okay, we're going to implement caching, and we're not going to hit the server again for my root page. So this page right here, chances are the location of customers and transactions isn't going to change very often. So we could instruct and say, you should cache this one, and set a long cache expiration for it. And similarly, before you ask your next question and beat me up more, we can design the API differently too, right? So I could, based on whatever the information that you think a client may want to consume, if there is a particular operation where you're concerned about performance, then you can put that higher in your hierarchy, right? So you can, as a server developer, you say, oh, you know what? I'm noticing a pattern where a lot of clients are having to navigate through this link, then the next link, then the next link to go through the system. I'd like to give them a way to just get to that root, what the information they care about. So I can construct a new affordance, a new link or a new query or something that allows them to get to the information they care about without having to do all those jumps. So this is just like to illustrate the concept, but we could do whatever to get through it. Is that?
So I see that you don't need to hard code the endpoints, but you need to figure out how to traverse your collection. So you're training one for the other.
So this is what I was talking about the difference between protocol state and application state, or semantics, protocol semantics versus application semantics. This isn't like a silver bullet. It's not magic. It's not going to fix all of the problems. It's just an evolutionary step, not a revolutionary one. So you still, the semantic meaning of customers and transactions is something that if you hard code it in a client app, you can't get away from the fact that that can't change, right? That's not going to solve that problem for you. But if, let's say, like in this example, we wanted to put that service somewhere else. We wanted to change the URL pattern. We wanted to restructure things server-side. As long as we keep these rels and we don't break semantic applications state or the transforms, and we don't change the state machine, the client's going to be able to read and respond to those changes server-side. So it's just giving us a few more tools to work with on the server side to be more descriptive and be a little bit more resilient to change. But the fundamental big stuff like that, the semantic gap, is something that's V next or V never. Yeah.
So this is about the server side.
Mm-hmm.
Usually, let's say I want to get a list of customers on the server side. I get this data from somewhere, let's say Mongo, whatever. I build some JSON structure and send it to the client. Now, that's not good enough with this. I have to add to the data I get some of these new fields. Are there libraries that help me to do that without myself having to go manually build this JSON structure?
Yes, there are a few of them. We can talk about it after. I don't have them linked out. But if you do like a search for collection plus JSON, you'll see there's a .NET library. There's one. This is in Python. I have semi-open sourced it. It's out there on GitHub, but I haven't like really publicized it. I know there's one for Rails. I know there are some for Node. I don't know all of the breadth and scope. This is this is still early on in the development of a lot of this stuff, and so I think you'll see more on the server side first and then more client-side support for it after. And so there's a little bit of both right now, but the server side seems to be more mature from what I've found. So there is some things to help with it, but it's not like a full-fledged framework for handling every single edge case. But it's also, I wrote the stuff that drives this in about 2 weeks. It's not that difficult to take an existing framework and adapt it into that. But it depends on what you're starting with. If you're starting with completely unstructured Mongo documents, it's going to take a little bit more to map it, just like it would for any other change. All right, yes?
So as you're going through the links in this example, you keep going deeper and deeper into it. Does it make sense to create links that also take you back the way you came? Or is that just...
I mean, yeah, depending on how you think your consumer is going to consume your API. And so I've been doing a bad job of repeating the questions for the video, but the question was, does it make sense to have links go back? And so if you saw for the pagination example, I had a link to go back to the previous page because I thought a consumer might be interested in that. And so if you find that as you're building your API, you can always add new links and affordances into your design so that a consumer or a client can navigate them. So yeah, you can definitely do that. Yeah. Okay.
Just one thing for the links, as you probably know, there is an RFC spec that has some of the links that are generic for everyone. Of course, you can create your own custom link.
Mm-hmm.
One thing I was wondering is, how do you handle actions like when you have a complex calculation? Do you use a form or do you send in a resource?
It would depend on the interaction, I guess. The question was, how do you handle more complicated computations? Would you send in a resource, or would you put in a form somewhere? And I guess the answer is it would depend on the type of calculation and how you'd model it. So I know it's not a great answer, but it depends on your. It's a tough answer or tough question to answer generically.
Yeah, that's true.
So one more question, and then you guys can ask me at the bar, because I think that'd be better for the rest of you. Let's. Oh, sorry. Who's using this stuff? Some people. Hey. And not a lot of people are super mature about it, but there are people doing it. It's growing. And here's an example of some companies that are sort of doing it. Cool. So sorry, I'll let you do one more question after that. But at the beginning of the talk, I asked you guys who's written or consumed a REST API. And it was sort of a trick question. I sort of lied because I think I may have convinced you that none of you or one or two of you have written a REST API, but all of you have consumed a REST API. All of you have used a web browser. All of you have used HTML, and probably a lot of you have written servers to display HTML. And so the same affordances, the same concepts that made the web successful and led to this massively distributed, awesome system that we use every day can be applied to your APIs. And so basically that's the goal of the talk, right? That's the idea of REST, is just to teach you that you can apply these same concepts to your web APIs and get a lot of the same benefits. So that's really all I have. Now I'll take any questions. One more question, I guess. You had your hand up, yeah.
So, I mean, I've done some video stuff, and the extra ceremony does have a little bit of overhead.
Mm-hmm.
Do you know any numbers about roughly how much that adds?
Probably depends on your format. If you're using HAL, which is a lot more lightweight, you're going to have less features in terms of your affordances, but you're going to have a more lightweight message transfer. If collection plus JSON, it's pretty heavyweight in terms of the number of affordances you have, which could lead to maybe more overhead, but then you can choose to give less. So it would really go on an app-by-app standpoint. And the idea is, I mean, again, this is not magic. There's no silver bullets. You still have to do performance analysis. You still have to do the thinking about how a person is going to consume your API, do analytics to determine how they are using your API, and evolve it over time. This is just giving you more tools to do those jobs. So, all right, bar time. Anybody that wants to go to the bar, you guys can head out. That's it for me. These are some resources. All right, thanks, guys.